So in this, we're going to cover mixed and entire radicals, what they mean, and how to move back and forth. So a mixed radical would be something like 7 root 2. So the mix is this coefficient and the radical. And if I wanted to turn it to an entire, well, what is 7? Well, it's the square root of 49. So I could say, well, that's the same as the square root of 49 times the square root of 2. And I can actually just mix these or turn them back into one entire thing. So that would be 49 times 2 and 1, which is actually just the root of 98. So in this, we've gone from a mixed radical to an entire. So there's other ways we could do this. We might have something like x times the root of 5. So that is the square root of x squared times the root of 5. And that would then equal the square root of 5x squared. Just shift the x behind it because that's a habit of having the coefficient in front of the x. What if I had, you know, x squared, and this is the third root of x? Well, that, I could take this, and I would just have to say, well, what is the third root of this? And in that case, that would be the third root of x squared is x to the 6. And that's times the third root of x. So here, what I did there is an exponent law, so that's something that you should review in a different video. I'll have that linked. But in this, now we can group them. So that's the third root, x to the 6 times x. And another exponent law is that that's x to the 1. We can add that. So that's the third root of x to the 7. So notice how this changes how many times I had to multiply that. So taking the square root, I only had to square it. I had to multiply it twice. In this, the third root, I had to multiply it by 3 times. So I took 2 and I multiplied by 3. So what if I wanted to go the other way? So what if I had something? So this is going mixed to entire. What if I wanted to go entire to mixed radical? Well, let's say I had the square root of 300. Well, that's just the root of 100 times 3. And I know the root of 100, that's just 10. So let's do this. That's 10 squared times the root of 3. So that's just 10 root 3. We can do that with, let's say, a. Let's say I have the third root of a to the power of 4. Well, this I could break up into sections and say, well, that's just like a to the 3 times a to the 1. And the third root of a to the power of 3 is just a. So that's how we go that way. So we're essentially taking an entire radical and going to a mix. So sometimes this might be very useful. So what if we had something like, the square root of 25x. So here I could just say, well, I know what the root of 25 is, right? I know the root of 25, and I'll keep that as the root of x. Well, that's just 5 root x, which I think makes a lot more, it's a much simpler way of looking at this problem, and I find this to be more useful. And in general, I think that's a pretty good place to stop.